So at this point, we'll jump into what are VLFs and why should you care? And we've got some slides here from a presentation I did a few years ago that I was able to pull some of the content in and reformat it a little bit. But to start with, in SQL Server, most databases have a minimum of 2 files. You can have more, but generally you have a minimum of 2. And one of them is your data file and one of them is your log file. And as shown here, the log file is set up. This is just some default settings after creating a new database. And with this, the log file is what keeps track of transactions while they're running. And depending on whether you're in a full recovery model or a simple recovery model, the transaction log behaves differently. In simple recovery model, the transaction log is kept around for the duration, or what's written to the transaction log is kept around for the duration of a transaction. Once the transaction completes or is rolled back, what's in that log can be cleared out and used again. When you have full recovery model, that information stays in that log until the log is backed up. And there's a few other things that can impact it, like replication and log shipping, things like that. But until the log is backed up, your log file can continue to grow. And what we're going to look at is how inside of that log file, there's smaller pieces that are called virtual log files. And these are sequential pieces. And it basically starts out, when SQL Server allocates new log file space, the files are allocated in those chunks that are called VLFs. Now, depending on the version of SQL Server that you're using, those virtual log files are added in different number of chunks. So meaning prior to SQL Server 2014, and they've adjusted this a little bit since SQL Server 2014, I think it's much smaller numbers now. But prior to 2014, VLFs are added. If you have up to or less than 64 megabytes, you get 4 virtual log files. 64 megabytes to 1 gig, you get 8, and more than 1 gig, you get 16. And I think now, gosh, I should have checked the numbers on the latest version, but I think generally you're getting between 1 and 4, depending on the size, on databases newer than SQL Server 2014. Now, why does this matter? So this is just a big file. If you end up with too many VLFs or a high count of VLFs, that can really slow down your system. Mitch, can you think of some examples of how you might end up with too many VLFs?
You're making a lot of changes and it could just bloat your log file. You're doing just a lot of changes all at once and your transaction log's not going to roll over in time it won't roll over. It won't have time to roll over and you'll just keep sequentially adding them.
So like a really giant transaction. Yep,
Right.
That's definitely one. Another one that we see is where something happens, like for some reason people turn off their log backup job for a while. Right. And may turn it off for a couple of days. And during that time, the log file grows and grows and grows to a point that's way bigger than you'd ever need if you're doing proper backups. So yeah, a couple different scenarios there as to how you might end up with high VLFs. But the problem is not the size of the log, but the VLF size, or the number of VLFs and the VLF size themselves. So generally what we see is greater than about 500 to 1,000 VLFs, you can have serious performance issues. But also what we detect is we generally, when we're looking at things, we're looking at more than 250 and we want to figure out how to get it a little bit under control. But also if your VLFs are too big, that can cause problems too. So greater than about a gig in size for an individual VLF can be a problem depending on the overall performance of your system. So the way the log file works is as the log file expands, it just keeps putting these virtual log files on the end of it. And we're going to have a demo with Mitch in just a minute to talk about that. But as the file grows, it just puts on these chunks of varying sizes. As it grows, it just keeps putting these on the end of the file. And unless you do something to manually clean them up, they're just going to, the file gets allocated and it doesn't get cleaned up. So let's look at an example here. So if you had file growth with a default, let's say you just create database and go with the defaults of 1 megabyte for the log and 10% growth. And let's say the log needs to grow to 3.5 gigs. Well, what's going to happen is you're going to end up initially that 10% growth is you're going to get a lot of really tiny virtual log files. And then eventually, to get to 3.5 gigs, it'll grow out to be about 420 log files, and you get these really varying sizes of the virtual log files. Now, the problem with percent growth is as the database or as the files get bigger and bigger and bigger, that percent growth gets bigger and bigger. So it's a relative setting, and you end up in a position where you've got some really kind of mismatched sizes, where one transaction might span 30 VLFs and another one is fully contained in one VLF. So we usually want to clean that up a little bit, and we'll talk about that in a minute. But let's look at another example. Let's say you start big, you start with your log file at 2 gigs, 2000 megabyte, and you grow at 10% growth. So still the same 10% growth setting, but you started with a much larger file to begin with. Now, if the log file grows that same example of 3.5 gigs, well, the VLF count will be about 64, and the VLF sizes will vary a little bit, but they'll be up to 125 megabyte in size. So that's a little bit more manageable of an example. And then let's take a look at another scenario here is, and this one we're looking at, instead of 10% growth, we're looking at 500 megabyte growth. So half a gig per log file growth. And the log file would be 40, which would be a little bit less. And the VLF sizes would be around 125 megabytes to 250 megabytes, which is a pretty good spot for the sizing there. Now, Mitch, do you want to talk a little bit about what happens if you end up growing your log file too big? What can we do to deal with it if it ends up with like a real bad set of settings here that it's growing?
That's going to depend on where if the transaction log is rolled over recently, and we haven't gotten into it yet. But as you stated earlier, the log file creates these VLFs sequentially, and if the last VLF is still in use, we kind of just have to wait until that transaction log rolls over and freeze that up, which if your last few VLFs are just absolutely massive, that can cause a lot of problems waiting for those to actually roll over. So one of the big things that we recommend is getting the settings set up properly. And I was going to want to see if you want to clarify what's the difference between that 10% growth and the 500 megabyte growth.
Oh, yeah, let's go back and take a look at that. So 10% growth to 500 megabyte growth. Well, it's not that different here because it's with 10%, you grow to 64 VLFs, and with 500 megabytes, you grow to 40 VLFs. And that's not that big of a difference there really overall. But the difference is that as the file gets bigger and bigger, that 10% gets bigger and bigger. And
right,
as each growth happens, you might have multiple VLFs that are getting created as part of that. So by setting it to a fixed size, like 500 megabytes versus 10%, you know it's always going to be growing at a reasonable size. Now, one of the problems we run into is, gosh, we had one that had really small growth settings, and they had over 100,000 VLFs inside of their log file. And the problem we ran into was that on backup and restore, when we restored that database, that was a database that took us almost an hour to back up just because of the size. And then when we restored it, it took over 8 hours to restore the database. And like 7 of those hours were spent just recreating all those VLF chunks in that log file. And what we found was that with that same database, we shrunk the log and expanded it and got it back to the same size, but with fewer VLFs. So bigger chunks and fewer VLFs. And it took the restore time on that database from over 8 hours to be just barely over an hour. So massive time savings on restore. And you might say, well, how big of a deal is it if the restore takes a little bit longer? Well, if something catastrophic has happened on your system and your system is completely down, you've got your manager and the president of the company and everyone else looking over your shoulder and screaming as to why the site's not working. And you're just sitting there twiddling your thumbs saying, well, we're waiting 8 hours for this to restore. And you probably don't know it's VLFs, but if you knew, you'd say because the log file was set up poorly. That's a pretty bad spot to be in. And having had to do emergency restores for clients, we like to be able to do them as quickly as we can and not have to have that kind of an 8-hour lag on the restore. We're going to talk a little bit about how Database Health Monitor gives you some cool things to deal with the log files. But first, the old way, let's say you hadn't heard of Database Health Monitor or you don't have access to it. Well, you can go check the VLF count with dbcc log info, which is an internal command that will tell you how many files there are and how big they are and all that. And it just gives you like a table display. And then you can go adjust the settings on your database file or adjust the settings on SQL Server for that database for the growth. Then you go shrink it as small as possible and do this off hours. But you also need to make sure that that last one, like Mitch mentioned, the last VLF is not in use or it won't shrink past that. And then you shrink it as small as possible, grow it back to the size you need. And that might be close to the same size it was originally, but check the auto growth settings and make sure that your VLF count is coming out less with dbcc log info after doing this. If you don't adjust your auto growth settings, you may end up with just as bad of a scenario, depending on how you grow the file. But this is where we say there's a better way. The better way used to be a script that I had on my website at stevestedman.com, where you could download and run this T-SQL to sort of visualize in this character-oriented chart what the log file looked like. But after using that for a few years and realizing, hey, we've got Mitch working on Database Health Monitor, maybe he could put it in as a cool new report.